We usually just call it dirt. But what if I told you it's not just dirt? What if it's a living, breathing engine? The very engine that powers all life on our planet. Let's pop the hood and see what's really going on down there. Seriously, just think about that for a second. An entire bustling city, a metropolis teeming with billions of tiny inhabitants. They're all working, eating, building, and it's all happening right now, just inches beneath your feet. And no, this isn't some sci-fi movie. This is the actual reality of the ground we walk on. So, this incredible underground city, it's got a name, the Soil Food Web. It's this super complex network of organisms, and it's what powers, well, everything. Our forests, our farms, ultimately it powers us. You can think of it like a community where every single member has a critical job to do. All right, so let's get into the nitty-gritty. How does this hidden engine actually work? What are the mechanics? Okay, first off, we've got to talk about scale, because this is just mind-blowing. In just one handful of healthy soil, you're holding billions of organisms. Billions! It's not just some empty space. It's a packed metropolis of microscopic life. Bacteria, fungi, protozoa, living right alongside bigger guys like earthworms and beetles. So with billions of residents, how is this massive community even organized? Well, like pretty much any ecosystem, it all boils down to one thing: the flow of energy and nutrients. So here's how it works. It all kicks off with the producers. That's our plants, soaking up energy from the sun. Then you've got the decomposers. Think bacteria and fungi. They're the cleanup crew, breaking down all the dead stuff. After them come the consumers, like protozoa and nematodes. They eat the decomposers, and when they do, boom, they release nutrients that the plants need. And finally, you've got the predators, your spiders and mites, who are basically the regulators, keeping everyone in check. It's this beautiful, self-sustaining loop. And where does all the fuel for this engine come from? Well, it all starts right here with photosynthesis. We've all heard of it, right? Plants grab carbon dioxide from the air, water from the ground, add a little sunlight, and they create these simple sugars. That chemical formula you see? That's the good stuff. It's the primary energy source for the entire web. But here is where it gets really interesting. Plants don't just hoard all that energy for themselves. Not even close. They actually pump somewhere between 20 and 40% of it right back down into the soil through their roots. Now, why on earth would they give away so much of their own food? Well, the answer is something called root exudates. You can think of them as liquid gold. Or maybe a better way to put it is, it's currency. Plants are literally using these carbon-rich sugars and proteins to pay for services. They're trading this cash with microbes to get essential nutrients and even protection from diseases. It's an absolutely brilliant partnership. Okay, so we've talked about the microscopic world, all these chemical deals happening. But it's not just the little guys. There are much bigger players at work here, physically building and shaping this underground city. Let's call them the soil's engineers. So, let's meet the construction crew, shall we? First up, you've got the earthworms. They're the master architects, digging these amazing tunnels that let air and water flow deep into the soil. Then you've got your arthropods, your beetles and such. They're kind of like the demolition team, shredding up all the organic matter into smaller bits for the microbes. And hey, even vertebrates like gophers get in on the action, burrowing around and mixing up the soil layers. And don't underestimate the impact of just one of these engineers. I mean, just look at this. This shows the earthworm effect. Their casts, which is a nice way of saying their poop, are absolutely packed with way higher concentrations of key plant nutrients. Look at the difference in nitrate, phosphorus, potassium. They are literally little fertilizer factories moving through the soil. So what this all really means is that the world below our feet isn't some separate, isolated system. It's deeply, intimately connected to the world we see above ground. You could even say they're in a constant, living conversation with each other. And this quote just hits the nail on the head, doesn't it? Plants don't just live in soil. They actively cultivate their own microbial community. That's so powerful. They aren't just sitting there hoping for the best. Nope. They are active farmers using those root exudates, that currency, to grow the exact microbial community that helps them thrive. And the benefits for the plant are just incredible. For instance, some of these friendly microbes can kickstart something called induced systemic resistance. Now that sounds complicated, but the analogy is perfect. They basically vaccinate the plant. They trigger its natural defenses, switching on its immune system so it's ready to fight off diseases before they even become a problem. How cool is that? But, this is a complex, finely tuned engine. So what happens when it breaks down? What are the real risks when this system collapses? And maybe most importantly, can we fix it? Well, a healthy system has one key characteristic: resilience. It's the ability to bounce back from stress, like a drought or flood. And that strength comes from something called redundancy. It basically means you have multiple different species that can all do the same job. So if one group struggles, another one is there to pick up the slack. But what happens if you take out entire functional groups? If you get rid of, say, all the decomposers or all the predators? Suddenly, that safety net of redundancy is gone. The system gets weak. And if the damage is bad enough, the whole thing, it risks a total collapse. And the signs of a collapse are pretty stark. The nutrient recycling we talked about, it slows way down or even stops. Organic matter just piles up on the surface without breaking down. Plant diseases go wild because there are no predators to keep them in check. And this isn't some abstract problem. It hits us right where it counts, threatening our food security with crops that have fewer and fewer nutrients. Okay, so that's pretty serious. But it's not a hopeless situation. This engine can be repaired. The question is, how do we restart it? Well, the solutions are all about working with nature instead of against it. Things like adding compost and biochar to reintroduce a ton of beneficial microbes back into the soil. We can plant diverse cover crops so there's always something growing, always feeding that underground web. And this one is huge: reducing tillage, plowing. That protects the actual homes and networks these organisms have worked so hard to build. When you boil it all down, what's really needed is a big shift in how we think. We have to stop treating soil like it's just some inert resource we can mine and extract from. We need to start seeing it for what it is: a living community that we have a responsibility to care for. It's a shift from simple extraction to true stewardship. So, we've taken a journey into this invisible city that's right under our feet. We've seen how this incredible engine works, and we've seen what happens when it breaks. So the real question isn't just about the soil anymore, is it? It's about us. Knowing all this, what are we going to build on top of this living foundation?